Hello, ladies and gentlemen. Today we're going to be reviewing how to write parallel and perpendicular lines, how to write the equations of those lines. And we're going to talk about parallel lines and perpendicular lines and just some more facts about them that you should already know. So what you're going to need today are your notes, a pen or a pencil, and a calculator, maybe if you want one, okay? So just like usual, note-taking things that we need, notes, pen, and calculator if you so desire. So let's refresh our brains. What do we already know about parallel and perpendicular lines? Well, we know that parallel lines never intersect. We know that they have the same slope. And we know that multiple parallel lines are going to be parallel to each other, no matter how many. So you don't just have like two parallel lines, you could have three, you could have four, you could have 50 million parallel lines, okay? And we know that it can be written in slope-intercept form, which is y is equal to mx plus b. What do we know about perpendicular lines? Well, perpendicular lines intersect at a 90-degree angle. So when we graph them, instead of parallel lines look like this, those are slightly not parallel, but you get the idea. Perpendicular lines intersect like this, like a cross in the road, or a T, or a coordinate plane. But they create four 90-degree angles at that intersection. So here's another 90, 90, 90. And we learned in the last video that they have opposite reciprocal slopes. Remember, the opposite means the sign and the reciprocal means the number, and they have to have both in order to be perpendicular lines. And we also know that these lines can be written in sloped intercept form, which is y is equal to mx plus b. All right, today we're going to go through examples of how to write the equation of some lines using what we know already about parallel and perpendicular lines. So when we write an equation of a line, our final answer is always going to be in slope-intercept form. And slope-intercept form is y is equal to mx plus b. So no matter how you want to get there or how you want to figure it out, our final answer has to be in this form, which means we have to find M and B for each one of these problems that we go through today. So let's read the first example. Write an equation in slope-intercept form of a line that passes through the point 3, 1 and is parallel to the line f of x equals 2x plus 4. So I already know that my M, because parallel means same slope, is going to be 2. But now my question is, what's B? How am I going to figure out B? Well, I'm going to have to use the point that they gave me to figure out B. So if I want my final answer to be y is equal to mx plus b, they gave me an x value and a y value of this ordered pair. So in order to figure out b, I can plug in all the things that we know. We know x is 3, y is 1, and m is 2. So y is 1, m is 2, x is 3, and then we can find b. So 2 times 3 is 6. So we have 1 is equal to 6 plus b. In order to get b alone, we're going to have to subtract 6. So b is equal to negative 5. But that's not my final answer. My final answer has to be an equation, which means I need to say y is equal to 2x minus 5. And that's my final answer. Okay, we're going to do the same thing now, but now they're asking me to write the equation that passes through the point 6, 6 and is parallel to the line f of x is equal to 1/3 x minus 1. It's still parallel, which means that my slope is going to be 1/3, but I still got to figure out what that b equals. Okay, you guys, so when you were in Algebra 1, you learned slope-intercept form, which is y is equal to mx plus b. But you probably learned this form, which was y minus y is equal to m times x minus x, which is called point slope form because you've been given 2 points and a slope. That's where this comes from. So when you solve these problems, how we did example number 1, you can solely use slope-intercept form and plug in m, y, and x and find b, and then at the end plug in m and b for your final equation. Or you can find the equation of this line using point-slope form, and I'll show you what I mean. In point-slope form, you always keep the first y and the first x as the variable, and then the second y and x is the value that you're going to plug in from the point that our problem gave us. And we know that this 1/3 is going to be plugged in for m. So if we plug in y minus 6 is equal to 1/3 times x minus 6, if we just distribute and solve for y, we'll end up getting an answer in slope-intercept form. So distribute that 1/3, so we have y minus 6 is equal to 1/3 x. 1/3 times the negative 6, when you distribute this, you're going to take 1 times the negative 6 over 3 times 1 is 3. So you get negative 6 divided by 3 is a negative 2. And then we have to add 6 to both sides to get y alone, which gives me y is equal to 1/3 x plus 4, because negative 2 plus 6 is 4. So you can solve each one of these problems either way. Either way will work, and you should get the exact same answer in the end for the equation of the line. Whether you want to use slope-intercept form or if you want to use point-slope form to get there. In any case that you use, or in either case that you use, your final answer needs to be in slope-intercept form. Needs to be in slope-intercept form. So it has to be in y equals mx plus b. But you can use point-slope form to get it there. I don't care how you want to do it. I'm going to do the next 2 problems, one of each. Okay, example number 3, I'm going to solve it just like I did example number 1. I'm going to use just slope-intercept form. So I need to write an equation in slope-intercept form in the end of a line that passes through the point 4, 8 and is perpendicular to the line negative 2x minus 4. Perpendicular means opposite sign. So since this is negative, I want a positive. And then the reciprocal number. So the reciprocal number to 2, which would be 1/2. That's what my m is going to be. And they already gave me an x and a y value. So I'm going to use slope-intercept form, y equals mx plus b, where y is my 8, m is my 1/2, x is my 4, and I need to solve for b because they didn't give me that. I need to find it, okay? So 8 is equal to 1/2 times 4 is 2, plus b. In order to get b alone, subtract 2, and b is 6. So that means that my final answer is going to be y is equal to m is 1/2 x plus 6. Because my final answer needs to be an equation of a line. It's not good enough to find just m and b. I want the actual equation of the line in slope-intercept form, which is y equals mx plus b. All right, now I'm going to use point-slope form to solve this one just like I did in example number 2. So I need to write an equation that passes through the point 6, 0 and is perpendicular to the line y is equal to 3/2 x minus 6. So point-slope form is y minus y is equal to m times x minus x, where these are the ones that we're plugging in for numbers or values. So this one, and this one are all going to be given a number. But first, let's figure out what my m is going to be if it's perpendicular to the current one. So it's the opposite sign. Well, I've been given a positive one. If I want the opposite, it's going to be negative. And the reciprocal of 3/2 is 2/3. So my m is going to be a negative 2/3. So now I need to plug in x and y into my equation. So y is 0, so it's going to be y minus 0 is equal to my m is 2/3 times x minus the x of my ordered pair is 6. So y minus 0 is just y. Now we have to distribute this negative 2/3. So we get a negative 2/3 x. And when we distribute negative 2/3 times a negative 6 over 1, you're going to multiply negative 2 times a negative 6 is a positive 12. All over 3 times 1 is 3. So we get y is equal to a negative 2/3 x, all plus 12 divided by 3 can be simplified to 4. So that's my final answer. Hopefully this is starting to make sense when I say you can solve either way, but your final answer, you guys, has to be in this form, that slope-intercept form, okay? All right, here's an example. Write an equation in slope-intercept form of a line that passes through the point -1, -1, and is parallel to this function or this equation, y is equal to negative 2x minus 4. This problem, you guys, I want you to try on your own, okay? I want you to try it on your own in your notes. And if you want extra practice, so you can get a practice problem on parallel and perpendicular, here's another problem for you to try on your own, okay? So these are not in your foldable, but you can try them on your own. I want to thank you all for taking such good notes, and I shall see you soon.